The thought of a supermassive black hole suddenly changing its position and heading towards Earth is undeniably terrifying. A recent discovery by NASA suggests that such a scenario could happen, albeit unlikely. The black hole in question is far enough away that we need not fear imminent danger. It is at the center of another galaxy and is moving away from us rather than towards us. However, the implications of this discovery are profound and disturbing. The black hole of galaxy P2339, originally identified as a typical radio galaxy, shocked astronomers when the supermassive black hole at its center drastically changed direction by 90 degrees. This event, reminiscent of a scene from a horror movie, transformed the galaxy into a blazar, a type of radio galaxy whose radiation is directed directly to Earth. The phenomenon of jets, energetic bursts of radiation hundreds of thousands of light-years long, has become a center of research for scientists. Blazars are fascinating cosmic spectacles, especially when they are far enough away. Their jets, composed of charged particles traveling at nearly the speed of light, emit bright and sometimes flickering radiation toward Earth. The sudden change in direction of the black hole P2339 is still a scientific mystery, which could be caused by a collision with another galaxy or internal dynamic processes. Supermassive black holes are very dense objects with masses millions or billions of times that of the Sun. They exert enormous gravitational forces, trapping light and influencing the behavior of the stars and gas around them. Scientists believe that black holes play a crucial role in the formation and evolution of galaxies. Galaxies begin as large clouds of gas and dust that collapse under their own gravity and eventually form a supermassive black hole at their center. The processes that form galaxies are complex and involve several chain reactions where one event leads to another. The relationship between black holes and galaxies involves feedback mechanisms where the activity of the black hole affects the galaxy as a whole. Active galactic core feedback can enhance or limit the growth of a galaxy, determining its final size and structure. Although black holes are not the creators of galaxies, they are necessary for their growth and formation. Despite the constructive role of black holes in space, they also present potential dangers. The nearest known black hole, 616 Manoceros, is about 3,000 light-years away, which provides some certainty. But the existence of wandering black holes in our galaxy is still possible. Sagittarius A*, the supermassive black hole at the center of the Milky Way, is 26,000 light-years away and has a stabilizing effect on stars, including our Sun. Jets from supermassive black holes play an important role in energy transfer within galaxies. These charged particles can influence the interstellar medium far beyond the boundaries of their host galaxies. By studying these jets with advanced instruments such as the James Webb Space Telescope, scientists can gain a deeper understanding of their composition, dynamics, and impact on the cosmic environment. Modern telescopes and observatories provide astronomers with detailed information about black holes and their behavior. The James Webb Space Telescope and its highly sensitive instruments allow scientists to study the jets in real time by analyzing their chemical composition, temperatures, and speeds. This technological advance is helping scientists unravel the mysteries of black holes and their role in the universe, leading to more accurate models of galaxy evolution. Black holes, especially supermassive ones, are objects with a huge gravitational pull because their mass is concentrated in a very small space. This gravity is so strong that even light cannot escape a black hole if it crosses a certain limit called the event horizon. The gravitational influence of black holes extends far into the surrounding space, affecting the movement of stars, gas, and other celestial bodies in their vicinity. The gravitational forces of black holes play a decisive role in the formation of the structure of galaxies. At the center of many galaxies, including our Milky Way, is a supermassive black hole. This central black hole affects the motion and arrangement of stars and matter around it. For example, in spiral galaxies, the black hole's gravitational pull helps maintain the structure of the spiral arm, influencing stellar orbits and gas distribution. Black holes also affect star formation in galaxies. As matter is pulled towards the black hole, it forms an accretion disk where the material heats up and emits radiation. This radiation can trigger star formation by compressing nearby gas clouds. On the other hand, The intense energy and radiation of the black hole can also heat and ionize the surrounding gas, preventing it from cooling and collapsing into new stars. This dual role means that black holes can both stimulate and inhibit star formation, depending on the conditions. Black hole jets and winds, consisting of fast particles and radiation, can transport matter away from the black hole surroundings. These jets can reach thousands of light years away, affecting the interstellar medium and even other regions of the galaxy. Ejected material can enrich the interstellar medium with heavy elements, influencing the chemical composition and distribution of matter in the galaxy. Black holes have a dual nature in the cosmos as both destructive and creative forces. On the other hand, their immense gravity can pull and destroy stars, planets, and gas clouds that get too close. On the other hand, the energy and radiation released by black holes during these processes can stimulate star formation and drive the evolution of galaxies. This dynamic interaction highlights the complex role of black holes in the universe. The relationship between black holes and their host galaxies is crucial to understanding the formation and evolution of galaxies. Black holes act as central engines that influence the growth and structure of galaxies over billions of years. By studying black holes, astronomers can learn about the processes that form galaxies and the large-scale structure of the universe. This complex relationship underlines the importance of black holes in cosmic evolution and the constant change of the universe. While black holes are fascinating and important to the dynamics of galaxies, they can also be destructive. The enormous gravitational forces they exert can destabilize celestial bodies that come too close. Fortunately, current astronomical evidence indicates that Earth is not threatened by nearby black holes. However, the cosmos is full of surprises, and the study of black holes is constantly revealing new insights into how our universe works.